We must now cast our minds forward, beyond the eras of human history, beyond the lifetime of the sun, and into the deep, unfathomable expanses of the cosmic future. For the story of dark matter is not merely a history of the past, but a prophecy of the end. The cosmic web, that grand, invisible cathedral we have spent so long mapping, is not a permanent fixture of reality. It is an ephemeral structure, a momentary gathering of ghosts in the vastness of time. We are currently living in the peak era of the web, the stellariferous era, where the filaments are thick with galaxies, and the nodes are bright with the fire of fusion. But the seeds of the web's destruction were sown in the very energy of the vacuum itself. We have spoken of the drift, the gravitational pull that draws matter together. But we must now confront the drift's great adversary, the accelerating expansion of the universe, driven by the enigmatic force known as dark energy. This force, which constitutes nearly 70% of the energy budget of the cosmos, acts as a relentless anti-gravity, a pressure that swells the space between the galaxies. For the first few billion years of the universe, the density of dark matter was high enough to act as a brake, slowing the expansion and allowing the web to weave itself into existence. But as the universe grew, the dark matter was diluted, spread thinner and thinner across the widening void. Dark energy, however, is a property of space itself. It does not dilute. As more space is created, more dark energy appears, its strength remaining constant per unit of volume. Approximately 5 billion years ago, the scales tipped. The jerk of the universe occurred, a transition where the braking ceased and the accelerator was pressed. We are now coasting into a future where the expansion is exponential, a runaway train that threatens to tear the cosmic web asunder. The first casualties of this war will be the filaments, these tenuous bridges of dark matter and gas, which currently funnel nutrients into the galaxy clusters, are being stretched. As the voids expand, the filaments are becoming longer and thinner. Eventually, the expansion will be too fast for the dark matter particles to overcome. The gravitational flow will be arrested. The river will run dry. The supply of fresh gas falling into the clusters will cease, and the filaments will snap, dissolving into the background density of the universe. The great highway system of the cosmos will be dismantled, leaving the galaxy clusters as isolated archipelagos in an ever-widening ocean of dark. This process is already beginning. The largest superclusters we see today are likely the largest structures that will ever form. The drift has hit a wall. The era of construction is ending, and the era of isolation is beginning. Let us focus on the fate of our own home, the local group. We are bound by gravity to the Andromeda galaxy and a retinue of smaller dwarf galaxies. This local knot of dark matter is dense enough to resist the push of dark energy, the expansion of the universe, will not tear the Milky Way apart, nor will it separate us from Andromeda. In fact, the drift here is destined for a violent but creative climax in approximately 4 to 5 billion years, just as our sun swells into a red giant and consumes the inner planets. The Milky Way and Andromeda will collide. It will not be a collision of stars, but a merger of halos. The two great spheres of dark matter will pass through each other, oscillate, and eventually settle into a single, massive, football-shaped halo. The spiral arms will be destroyed. The gas will be consumed in a final, brilliant burst of star formation, and the two galaxies will become one giant elliptical galaxy, often dubbed Milkomeda. However, while we merge with our neighbor, the rest of the universe will be waving goodbye as the expansion accelerates. The distant galaxy clusters, the Virgo cluster, the Coma cluster, the Great Walls and filaments, will be carried away from us at speeds exceeding the speed of light. They will cross the cosmic event horizon, a point of no return beyond which no light can ever reach us. One by one, the galaxies will blink out of the sky, redshifted into invisibility, their photons stretched to infinite wavelengths. In 1 trillion years, an observer standing on a planet around a red dwarf star in Milkomeda will look up and see nothing, no other galaxies, no cosmic web, no background radiation, for the cosmic microwave background will have faded to an undetectable whisper. To these future astronomers, the universe will appear static, eternal, and limited to their own single island of stars. They will have no way of knowing that there was once a vast web, no way of knowing about the Big Bang, no way of knowing that the dark matter halo they inhabit is just one of billions that have drifted away into the void. The evidence of cosmology itself will be erased by the expansion. We are privileged to live in the brief window of time where we can see the web, where we can trace the drift, where the history of the universe is written in the sky for us to read. In this deep future, the nature of the dark matter drift will change. With no external galaxies to interact with, no fresh gas falling in from the filaments, the Milkomeda galaxy will settle into a long, quiet senescence. The dark matter halo will become a relaxation machine. Over countless eons, the gravitational interactions between the dark matter particles and the stars will exchange energy. This process, known as dynamical friction, will cause the lighter objects, the stars, to gain energy and migrate to the outskirts of the halo, while the heavier objects, black holes and neutron stars, will lose energy and sink to the center. The galaxy will stratify. The dark matter itself, if it is made of WIMPs, may continue to annihilate in the dense center, providing a faint, steady source of gamma rays, a dying ember in the heart of the galaxy. But there are other, more exotic possibilities for the end of the drift. depending on the precise nature of dark energy. If dark energy is truly a cosmological constant, represented by lambda in Einstein's equations, then the expansion will continue at a steady, exponential rate, leading to the big freeze, or heat death described above. The universe effectively becomes empty and cold, a vacuum dominated by the lonely drift of isolated particles. However, if dark energy is phantom energy, a substance where the density increases with time, then we face the big rip. In this terrifying scenario, the phantom energy becomes so strong that it overcomes all gravitational bonds. First, it would tear the galaxy clusters apart, dissolving the web. Then it would rip the galaxies themselves to pieces, unbinding the stars from the dark matter halos. Then it would tear solar systems apart, ripping planets from their stars. Finally, in the last fraction of a second, it would overcome the electromagnetic and nuclear forces, ripping atoms apart, leaving the universe as a sea of subatomic particles, unable to interact. The drift would end in a shredding of reality itself. While current data suggests this is unlikely, preferring the big freeze, the dark sector holds enough mysteries that we cannot rule it out entirely. There is also the question of the stability of dark matter itself. Is it truly stable? Protons, the building blocks of our visible world, are thought to be stable for at least 10 to the power of 34 years. But what of the dark particle? If dark matter decays, even on a timescale of trillions of years, the web will eventually evaporate. Imagine the invisible skeleton of the universe slowly turning into radiation, into neutrinos or photons. As the dark matter decays, the gravitational potential wells would shallow. The galaxies, no longer held together by the heavy hand of the halo, would expand and dissolve. The stars would drift away from one another, unbound, wandering alone into the dark. The web would not just be stretched by dark energy. It would sublimate, turning from solid ice to gas, leaving behind a universe of pure radiation, a sea of light with no eyes to see it. Yet, even in the face of these immense timescales and terminal destinies, the current drift remains a thing of profound beauty and complexity. We are learning that the dark matter is not just a background stage. It is a reservoir of history, the phase space of dark matter, the record of the positions and velocities of every particle, encodes the memory of everything that has happened, every merger, every collision, every collapse is written in the twists and folds of the dark matter sheet. Theoreticians speak of the dark matter sheet folding in on itself in six-dimensional phase space, like a piece of origami folded billions of times. The galaxies are merely the places where the paper is creased, where the density is high. If we could read the full phase space of the dark matter, we could rewind the movie. we could see the trajectory of the Milky way back to the Big Bang. The information is there, held in the cold, silent drift of the particles. This brings us to a philosophical confrontation with the Copernican principle. Copernicus taught us that the Earth is not the center of the solar system. Shapley taught us the Sun is not the center of the galaxy. Hubble taught us the galaxy is not the center of the universe. And now, the study of dark matter teaches us that we are not even made of the primary stuff of the universe. We are the foam. We are the minority to an alien observer made of dark matter. If such a thing were possible, the beautiful spiral arms of the stars would be insignificant, a faint tracer of light in the massive, complex, and rich structure of the dark halo. They would study the dark web as the real universe and look at the baryons, the protons and neutrons, as a nuisance, a baryonic bias that complicates their clean gravitational equations. We are the ghosts in their machine, and yet it is the baryons that shine. It is the ordinary matter that can form complex molecules, that can condense into planets, that can give rise to biology, to consciousness, to eyes that can look up and wonder. Dark matter provides the cradle. Ordinary matter creates the life. The drift of the dark matter created the quiet, gravitationally stable environments necessary for billions of years of evolution. Without the dark matter holding the Milky Way together, our sun would have been flung into the void long ago. Without the filaments feeding gas to the galaxies, star formation would have ceased before the Earth was born. We are here because the dark matter drifted, because it slumped, because it held on. We are the beneficiaries of the dark sector's labor. As we continue our surveillance of the sky, new anomalies hint that the story is not quite over. The Hubble tension, a significant disagreement between the rate of cosmic expansion measured from the early universe and the late universe, suggests that our model of the dark sector is incomplete. Perhaps there is an early dark energy that existed briefly after the Big Bang and then vanished. Perhaps dark matter interacts with dark energy in a way we have not modeled. A coupled dark sector, where energy flows between the two fluids, altering the drift over time. These tensions are the cracks in the wall where the light comes in. They tell us that the script of the universe is still being written, or rather, that we are still learning to read the language. In the laboratories of the future, we may finally catch the particle. Imagine the paradigm shift if a detector in South Dakota suddenly lights up with a confirmed signal. We would know the mass of the ghost. We would know its cross-section. We could then simulate the universe with perfect accuracy. We could predict the drift of every halo. We could confirm if the center of the galaxy is full of annihilating particles. It would be the final piece of the Copernican revolution, the moment we physically touch the dominant material of reality. Until then, we are detectives, deducing the shape of the invisible man by the footprints he leaves in the snow. The footprints are vast. The Great Wall, the Sloan Great Wall, the Boss Great Wall. These are structures of dark matter spanning billions of light years. The largest things that have ever existed. They are the continents of the universe. And we are tiny ants crawling on a single grain of sand on a beach at the edge of one of these continents. The drift of these walls is slow, majestic, and indifferent to our presence, but by understanding it, we extend our minds to encompass the scale of the real. We stop being creatures of the earth and become citizens of the web. As we approach the final movements of this narrative, we must prepare to synthesize the journey. We have traveled from the hot, dense soup of the Big Bang, where dark matter was the seed, through the epochs of structure formation, where it was the builder, to the present day, where it is the invisible glue, and into the future, where it will be the lonely survivor. The drift is the timeline of the cosmos. It is the metronome of eternity, beating a slow, gravitational rhythm that underpins the frantic dance of the light. In the final part, we will bring this cosmic symphony to a close. We will look at the ultimate legacy of the dark matter research, the profound shift in human consciousness it represents, and leave with a final image of the universe that is both humbling and elevating. The dark is not empty, it is full. The silence is not an absence of sound. It is a frequency we are just beginning to hear. The drift continues, and we, for a brief, shining moment, are awake to witness it.